Hello everyone, welcome. Today we will be looking into IGCSE Unit 1 First Chapter States of Matter. I am Taskin and I hope that you will find this video useful. First off, what do we mean by states of matter? States of matter regards to the forms of matter, and for that we have three basic forms of matter. First off, we have solid. Second, we have liquid, and third, we have gas. How do the molecules look like here? The molecules in the solids are closely packed together with little to no intermolecular space between them. Here, molecules can only vibrate about in their fixed position. In liquids, however, molecules are apart from each other. They can easily slide over each other as well. In gas, the intermolecular space is maximum. There is so much space between them that there is almost no attraction, negligible attraction between the molecules. Here, the molecules have the highest speed, highest kinetic energy, and they are always moving around haphazardly. So we have seen the forms of matter. Now let's dive into their properties. For shape, solids have a fixed shape. They also have a fixed volume, and they do not flow easily. Also, they are not easy to compress. For liquids, they take up the shape of container. They can take up the shape of anything you put them in. They have a fixed volume as well. They flow very easily. And they are not easy to compress either, just like solid. For gas, they take the shape of the container as well. Of container, because they are free and they move around in lot of positions. The container you will keep them in, they will fill up the whole container. Then their volume can be changed. Volume is flexible here, and they also flow easily just like liquids, and they are very easy to compress. For our next part, we have conversion of states. Here we will be changing states from one state to another, solid to liquid to gas to solid. So when a solid when a solid changes to a liquid and that changes to a gas, what do we call it? Do you have any idea? Well, let me help you. That's why I am here after all. And this can also be done. The gas can directly change to solid. Solid can also directly change to gas. So what are these states called? From solid to gas, we call it sublimation. From solid to liquid, we called it melting. From liquid to gas, we called it boiling. And from gas to solid, we called it deposition. Again, gas can also change to liquid, and liquid can also change to solid. What do we call this change of state? From gas to liquid, we will call it condensation. From liquid to solid, we will call it freezing. So the number of changes of state we have got are sublimation, deposition, freezing, condensation, boiling, and melting. Now, how does exactly melting occur? When heat is provided, molecules in solids gain kinetic energy, or also known as Ke, and vibrates faster. This breaks the strong attraction force between the molecules in solids, and molecules are now able to move around, forming liquids. The point where this occurs is called the melting point. Now, what do we mean by freezing? If a liquid is cooled, particles start to move slowly. Eventually, they move so slow that the forces of attraction between them will hold them in a fixed position, and the particles pack more closely to form solids. The point where this happens is known as the freezing point. Now, what do we mean by the boiling? Like, what is boiling exactly? When heat is applied to a liquid, particles gain a lot of kinetic energy and move fast enough to overcome the forces of attraction between the molecules. The particles separate wide apart and form gas. The point where this occurs is known as the boiling point. For example, the boiling point of water is 100 degrees Celsius. Next up, we have something similar to boiling. It is called evaporation. Very fast moving particles on the surface of any liquid will have enough energy to overcome the forces of attraction on their own and break away to form gas. This happens everywhere, like in any surface of any liquid. Now, what do we mean by diffusion? It is the movement of particles or molecules from a higher concentrated area to a lower concentrated area without the use of energy. An example is shown in the diagram. We have some factors affecting diffusion. The faster the diffusion, the greater the distance traveled by the molecules or particles. And the lighter the molecules, the faster they diffuse as well. Next up, we have solubility. But before we go into its definition, let's look at the things that is needed in solubility. We have solutes, solvents, and solution. What is meant by solutes? These are the substances that dissolves. Solvents are the liquid substances dissolve in, and solution is meant when solute and solvent are added together. Now, what do we exactly mean by solubility? Well, the mass of solute which must dissolve in 100 gram of solvent at that temperature to form a saturated solution is called solubility. Now, what do we mean by saturated solution? Well, saturated solution is a solution which contains as much as dissolved solid as possible at a particular temperature. There must be some undissolved solute present as well. There is also a formula for solubility, and that is solubility equals to mass of solute divided by mass of solvent into 100. We also have a solubility graph. Here, as you can see, in the x-axis we have temperature in degrees Celsius. It can be also in Kelvin or Fahrenheit. And on the y-axis we have concentration per 100 gram. According to this graph, we can see that as temperature increases, the concentration will also increase. This means as temperature is increasing, the amount of solute dissolved in solvent will also increase. That means a solvent will hold more capacity, more ability to dissolve a solute. For example, here we can see at 20 degrees Celsius, we have almost 70 to 60 concentration of liquid. And at 60 degrees Celsius, we have almost 125 concentration of liquid. As such, as the curve increases, so will the concentration and temperature increase. Here we have another complex graph of solubility. Here each solid has different shape of graph. Solid D has almost a straight graph, solid A has more of a curve, and solid B has the most curve. From this curve we can see how much solid can be dissolved per 100 gram of water. For solid A at 30 degrees Celsius, almost Here we have another complex graph of solubility curve. Here we have a complex solubility curve. For each solid there is different curve. For solid A, for example, we can see at 30 degrees Celsius the solubility is 40, and for solid C at 30 degrees Celsius the solubility is 30, and so on. We can see the solubility for each and individual temperature for all the solids. So as you have guessed, from this curve we can find out how much solid can exactly dissolve in 100 gram of water. Thank you so much for being with us till the end. Hope to see you next time.